Okay, there's been a slight, there's like an echo. There's been a slight change and I'm swapping places. I should have been third and now I'm second. So if you didn't want to see me and you're stuck here, then that's off. Right, my talk is called How to Ruin Kids' Games with Machine Learning. And it was originally scheduled for an hour, but as you will soon come to find out, the reason it's 15 minutes is because it did not work. It went horribly wrong. Nothing I did went to plan, so it got cut down to 15 minutes. I should have really edited this beforehand and got them to change the title. There's also no trains, so if you're here looking for trains in some kind of generative art project, you're out of luck. The new title of this talk is called How to Beat a Small Child at Guess Who, which is, well, you'll see how that went. So I have a 4-year-old, and obviously we've spent a lot of time over the last year and a half sitting in our house doing basically nothing. And the kid, we've got him playing games. We play a lot of board games, so we got him interested in playing games and stuff. And we went through all of the games we owned and ran out until he ended up in my mum's loft getting out games that I had when I was a kid, including Guess Who. And the kid, he loves it. He's surprisingly good at this game. For a 4-year-old, my 80s version, genuinely from 1980. It was secondhand when I got it as a kid. So, but age range 7 to adult. He's 4. He beats me literally every time. Like 90% of the games he wins. And so I was like, come on, this is how is he winning? Or is that he's 4? Like my logic skills have got to be better than a 4-year-old. So I had this idea because lockdown. Obviously, I had a lot of time on my hands. I came up with this idea that I was going to build a machine learning powered robot that could dynamically analyse the characters of Guess Who and come up with its own questions and like devise the optimal strategy to win against any opponent, including a 4-year-old. Oh, and just in case, actually, I forgot, if anyone's not played Guess Who before, which might be some of you, it's a very simple game of logic for kids where there's 24 characters, you each pick a character. The point of the game is that you have to work out who your opponent's character is before they work out who yours is through a series of yes and no questions about the features of the people in the game. And there's a little board, just look at that, there's a little board in front of you with the flippy down people, so you can eliminate people based on the answers to their questions. And I thought, this is there's so much we can do here, I can definitely make a robot that can beat him. And like I said, project did not work, and it ended up with a slightly less lofty goal of finding the best strategy to probably win a game using brute force and no robots. So onto the list of failures. Part 1, I broke the project down into 3 parts, all of which failed. Part 1, I thought, right, there's faces. We can do some kind of facial feature recognition. We can compare the people to each other, and we can get it to automatically work out some questions it can ask. Facial recognition is pretty standard these days. And there's so many tutorials online and facial recognition in 5 lines of Python. I thought, I can definitely do this. This sounds really easy. This was very naive of me to think, because that's not true. There were 3 main problems with this approach. Okay, so first of all, facial recognition in Python is really easy if you are using pre-trained models and looking for human faces. Pre-trained models do not work on cartoon faces, because although there's obviously stuff around faces and facial recognition and how well it picks out different people and whatever, but on the whole, people's faces have generally the same configuration, like a nose in the middle, some eyes at the top, and a mouth. Cartoons are not necessarily like this. They sometimes have really exaggerated features. They can have extra features, missing features. There can be weird shapes. So if you try and run, even though my people in the Guess Who game were reasonably realistic, if you tried to run a human trained model against the cartoons, it was totally unreliable, and it couldn't find the noses, all of the different landmarks. They were just it was finding ears as eyeballs and stuff, and it just didn't work. So that did not work. So my plan, step 2, was, well, I'll just try my own model then, obviously. Of course I can do that, that's easy. But no, that wasn't easy either, because the way you train a facial recognition model in normal land would be to take 5 or 10 images of a single person's face, and so it can then recognise my face and then look for it in a crowd or whatever, identify it in a crowd of people. But I did not have that. I had one version of every face, and I had 24 different faces, so I didn't have enough to train anything. There was a slight diversion into like cutting up faces and making kind of like a photo fit situation, but that was a bit of a dead end. It was fun though. But yeah, that leads me on to the third problem, which is facial recognition is not what you need for this at all. Anyway, facial recognition is that. It's about finding my face in the crowd of you lot. Whereas what I actually wanted to do was to identify different features of different faces and compare them to each other. And like obviously facial recognition stuff is magic, and doing measurements under the hood of like your relative nose to eye ratios and whatever. But that is not easy to do by yourself. And I did try that as well, like plotting out people's, like these cartoon faces with the little dots where the nose is, and then doing some trigonometry to work out the sizes and stuff. But it was like a lot of work. And I ended up with this really, really non-dynamic system where I still had to tell it what to measure. And it's like, well, actually, do you know what? I could just use a spreadsheet. So I did that instead. So that was part one. We're not having any dynamic facial feature stuff. So we're just using a spreadsheet. And by this point, I was kind of already sick of this project. So I thought, I won't write any code. I'll build a robot. Because obviously he's a 4-year-old. He doesn't understand the command line. He doesn't understand the beautiful code that I was writing in the background. He wants a robot that can flick the little things down. So I thought, all right, we'll do the robot. That sounds fun. And what's the best thing to build a robot out of? Obviously Lego. Cracked open the old Lego, got this really old Mindstorms kit from like 10 years ago, got that out, built myself a little robot arm, had to update the firmware on that, which was a challenge. I had to go and find around my friend's house to find a Windows 7 laptop that I could use. Everything on there was written in Python 2.7, which meant that I had to build a whole load of dependencies from source, which was quite painful. But I did, in the end, I got the Pi talking to the Lego, which was awesome. I could move this little arm around, but I'd built a miniature version, and it was really good. It flipped the little things down, and it worked really well. And I was like, this is promising. We're getting somewhere. We'll at least have a robot. So then I tried to build it in full size, and it turns out that didn't work. Partly because the pneumatics I was using for the flipper were from the 90s, from my Lego from when I was a kid, and all the seals had degraded, and so the pneumatics didn't actually work anymore. And because of Brexit, all of there's a huge market. This is a rabbit hole you can fall into like I did, but there's this huge market of secondhand Lego on the internet, and you can buy almost anything, but it's all in Europe, and so it's like cost 20 quid to get like one little piece delivered, and was going to take 6 weeks. And I was like, oh no, I can't be doing with that, because I've got to do a talk in like 2 weeks. Clearly I didn't plan ahead. So I was like, fine, ditch the robot. We won't have a robot, we won't have the facial recognition. At the very least, we can have a strategy so we can beat him. So, I moved on to the working out the questioning strategy, because again, naively, I was like, well, right, you can train computers to play chess, and chess is a really hard game. I can't play chess. But I can play Guess Who. Guess Who is simple. We can train something to play Guess Who. And so, that's where I started trying to train a neural network to play Guess Who. And the first thing you need to do, if you're training something to play a game, is to play a lot of that game, a lot. And the 4-year-old has a certain level of patience, but not thousands of games of Guess Who patience, not even 2 usually. So I had to build a little bot that could play Guess Who. And its first attempt, I didn't put a lot of effort in. I used my little spreadsheet from before, and it just picked a random feature and asked a question about that. And I played this against the kid, and the kid won. So, I mean, he's obviously got some kind of strategy that's slightly better than random. So didn't give him much credit. So I thought, okay, we can definitely beat him with something better than random. But in the course of playing this with him, I realised that the fundamental flaw in this project that I had not considered before is that there is actually very little strategy in this game. There is really only one way to win, and that's to ask your questions better than your opponent. And your opponent's actions have zero effect on what you're doing. It's like 2 independent people just trying to be the better, slightly better than the other one at asking questions. Which was an unfortunate realisation like 2 weeks ago. So I was like, all right, well, fine. I'll figure out what the strategy is, and I'll hard code it. I'll build my little bot, I'll beat the child, and I'll be happy. No one else will, but I will be happy because I will have beaten him. So obviously the best strategy is going to be, all right, if you've got 24 people and you want it to narrow it down to 1, the quickest and most efficient way to do that is going to be to reduce that field by about 50% each time. It's the lowest risk, highest reward kind of question you can ask. So I changed the strategy in the little bot and got it to work out what feature was sort of present in approximately 50%, or the closest to 50% of the population as I could. But what you might... Oh, I don't know how long it's been since you've looked... Oh, no, back. Oh, pants. There we go. How long it's been... This is the 80s version. Yeah, you may not have looked at this quite as closely as I have recently, and in such great depth and detail, but it's almost as if they've designed it so that you can't ask these questions, because there's not many features that are actually evenly shared or have a 50% sort of incident rate amongst the population. So like if you wanted to ask about people with white hair, there's like 5 out of 24. People with beards, there's 4 out of 24. So clearly, like, my strategy wasn't very good, because it's not much better than random, because you're still, like, 30% is not, it's not close enough to be, it's not efficient enough. So I had this cunning plan, this amazing plan that I could force it to find a 50% sort of combination on every move, because there's nothing in the rules only say it has to be yes or no question. It doesn't say how many things you can ask about. So I had this great plan, right? If I asked, does your person have a beard and white hair and beard or white hair or glasses? Because that covers 12 people fit into that category, yes or no. And I was like, this is amazing, I'm definitely going to win. Because if you do the sums, right, if you actually work out like the 50-50-50, you will definitely have guessed that person in either 5 or 6 turns. So all you've got to do is hope that the child is not that good, like it does it in less than 5 and then you're winning. But unfortunately, and I built the thing and I wrote the little algorithm and it played fine and it was really good, worked perfect every time, but the child, as soon as I asked him a question like, does your person have a beard or white hair or glasses, he was like, what? Nope, you can't do that, that's cheating, you're only allowed to ask about one thing. So that was a flaw, so I just was like, I had my strategy and it was working and it was going to beat him, but he wouldn't play with me anymore, which I guess is kind of winning, but you know. So in a last ditch attempt to make something that worked and would beat the child, I turned to Google, and it turns out that I'm not the first person to think of this problem. There is actually a person out there, actually there are multiple, but there's one particular person wrote a PhD thesis on the maths of the Guess Who best Guess Who strategy. And now it's all this like probability maths and stuff, which years ago I probably did understand, but right now I couldn't possibly do it. And it's like 4 pages of mathematical proof, which is crazy to me. But the basic premise of the strategy is that, say you're in this situation, you've got 10 people, it's your turn, you've got 10 people, your opponent's got 4 people. You don't just choose the 50% number out of that group of people, because if whatever you do, that'll cut you down to 5 people, you'll still be behind. So what you've got to do is you've got to up your risk level. You've got to find a question that will take you to so you have the same amount of people or slightly less if you're feeling brave. So you need to ask a question that's got like 60% of the features, so that you then get to like 4 people and they're on 4 people, and the other way around. If you're like very in the lead, you can ask a more risky question to try and speed up your advantage. And I actually thought that was quite clever. I actually thought I was quite clever because I understood the paper. But so I added this little algorithm as well. And by this point, the child was off doing something else. He didn't care about Guess Who anymore. He's only interested in things for like 3 days. So he wouldn't play with it anymore, so I had to get the bot to play against itself. And so I got some graphs. They're highly detailed. So the blue guy is player 1, and in this case, the blue guy's playing random. And these are my strategies, which I've named clearly, so you all know what I'm talking about. So you see random playing random is about 50-50. The 3 strategies that I'd calculated, the optimal is the just trying to find 50% ones. The 50 or die was the compound questions, and space race for long and winded reasons was the one where you adjust your risk based on the population, whatever. So it basically, if you choose any strategy that's not random, you'll probably win. Same if you switch it up the other way around. choose any strategy, you'll probably beat someone who's random. But like I say, I'm not giving him a lot of credit there, saying that he's just random. He clearly has a strategy because he almost always wins. So I thought, do you know what? He's not playing with me anymore. So I'm never going to get any proper results out of this. So the best thing I can do here is play it against itself. So one evening, I left my laptop up in the office, playing 160,000 games of Guess Who against itself, and pitted every strategy against each other. And these are the results. Also, obviously, very, very detailed. So yeah, player one versus playing all 4 things against blah, 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 all of them there. And you can see, if you take off the top row where you're just playing against a random opponent, you can see the secret to his success. It's all here, encoded in this beautiful graphic that I spent hours creating. It seems to be that as long as you don't play randomly, you will almost definitely win if you go first. So now you know the secret to being an ultimate award-winning, like gold medalist Guess Who player. It's to be player 1. I can't tell you how many hours and weeks and how much stress this has caused me, and the conclusion is go first. There you go. Thank you. Oh.